Hi everyone, welcome to AI Correct channel. This is Akash Gangwar and today we'll be studying Trigonometry Lecture 4 and we'll be talking about multiples of multiple angles in this lecture and also certain other important results. Okay, so let's start our lecture with two important results. The first one is sine of a plus b dot sine of a minus b. It reminds me the formula of a plus b dot a minus b because the outcome is also more or less similar. So let's see the derivation of this one. So we have sine of a plus b, that becomes sine A cos B plus cos A sine B multiplied by sine A cos B minus cos A sine B. Right. It's a simple brute force method. You're not using any trick over here. So let's try to multiply these terms. This term and this term it would give us sine square A cos square B. This term and this term would give us minus sine A cos A sine B cos B, right? This term and this term would give us cos A sin A sin B cos B, right? And this term and this term would give us minus cos square A sin square B. So this term and this term gets cancelled out. Now we are left with sin square A cos square B minus cos square A sin square B. So what we can do over here, we can write this as cos square B as 1 minus sin square B and cos square A as 1 minus sin square A dot sine square B. So basically we have converted everything into sine terms. So we have sine square A minus sine square A dot sine square B, and we have minus sine square B and plus sine square A sine square B. So this term gets cancelled out. Now we are left with sine square A minus sine square B. So we are getting the result sine square A minus sine square B, which more or less looks like A square minus B square if we do A plus B, A minus B. So you can recall this particular formula, and you might be able to remember this one as well, right? So it's more or less similar to that one. But that's just applicable for sine formula, sine of A plus B dot sine of A minus B. It's not applicable for cos of A plus B dot cos of A minus B. So let's try to derive this one as well. So this one we have got sine square A minus sine square B. Now you can also see that we can write this in the form of cos square as well. This becomes cos square B minus sine square A. How? You just have to do 1 minus cos square A and minus 1 minus cos square B. And this particular format would come out. So either ways, it's possible to write it. Okay. Now let's try to derive this one. Cos of A plus B dot cos of A minus B. Again, we'll start with the brute force method. That is cos A cos B minus sin A sin B multiplied by cos A cos B plus sin A sin B, right? Now the first term would be cos square A cos square B. Second term would be sin A cos A sin B cos B. Third term would be minus sin A cos A. So this one actually would be plus sin A cos A sin B cos B. And the last term would be minus sin square A sin square B. So again this middle term gets cancelled out. Now we are left with cos square A cos square B minus sin square A sin square B. So what we can do over here is cos square A 1 minus sin square B minus, you can convert this into 1 minus cos square A dot sin square B. So now we are left with cos square A minus cos square A sin square B minus sin square B minus sin square B cos square A. So this term and this term again gets cancelled out. Now we are left with cos square A minus sine square B. You can write this again in the other format as well. That would give us cos square B minus sine square A. Either ways it's possible. So you can write it as cos square A minus sine square B or cos square B minus sine square A. Both ways it is possible. So you have to remember these two formats and you have to remember these two formats. Right? Now let's try to solve this particular question. If a plus b equals to pi by 3, then find the value of cos square a plus cos square b minus cos a cos b. Now let's first try to understand the intuition behind this particular question. So after looking at this particular thing, cos square a plus cos square b minus cos a cos b, there are multiple thoughts which you can gather, right? The first thought can be a square plus b square minus ab. So we might multiply a plus b and divide by a plus b. So that would give us a cube plus b cube divided by a plus b, where a equals to cos a, b equals to cos b. Right? The first thought that comes to my mind is this one. But I can see that we're not getting any closer to the solution because of this one, because we cannot do anything with cos cube a plus cos cube b. Cannot do anything. So this particular thought is rejected. We're not proceeding forward with this one. The other thought comes to my mind is we have been given a plus b equals to pi by 3. So a equals to pi by 3 minus b. So what I can do, I can replace a with pi by 3 minus b. So it becomes cos square pi by 3 minus b plus dot dot dot. Right. But again, expanding this particular term, first we have to expand cos of, basically we have to apply cos a minus b kind of formula, expand it, and then again do the squaring. So again, that becomes a very tedious and long process, and we won't be going forward with that one. It might give us certain concrete solutions afterwards, but it becomes too lengthy to solve in that particular manner, right? So we'll be thinking of some alternative. So what alternative we can use over here? We can write cos square b as 1 minus sin square b. Why? Because we have to utilize this a plus b equals to pi by 3. And if I do cos square a plus 1 minus 1 minus sin square b, I'll be getting a term cos square a minus sin square b. That is nothing but that has a term cos of a plus b dot cos of a minus b. So we can utilize a plus b over there and we can proceed forward with that. So this is my third thought, and let's see how we proceed with that. So we have cos square a plus 1 minus sin square b minus cos a dot cos b, right? So this gives me 1 plus cos square a minus sin square b. That is nothing but cos of a plus b dot cos of a minus b minus cos a dot cos b. Now cos of a plus b is nothing but 1 by 2. So this becomes 1 plus 1 by 2. Cos of pi by 3 is 1 by 2 dot cos of a minus b minus cos a dot cos b. Now cos a minus b is 1 plus 1 by 2 times cos a cos b plus sin a sin b. Now I can see cos a cos b term over here and cos a cos b term over here. So we might do something conclusive from this particular approach. So we have 1 by 2 cos a cos b over here and minus cos a cos b over here. So it actually becomes 1 plus sin a sin b minus 1 by 2 times cos a cos b, right? So this is nothing but 1 minus 1 by 2. If I take minus outside, cos a cos b minus sin a sin b, that becomes cos of a plus b, right? Now again cos of a plus b is 1 by 2. So 1 minus 1 by 2 dot 1 by 2, that is 1 by 4. So answer is 3 by 4. Now let's talk about trigonometric ratios of multiple angles. So the first one is sine 2 theta. So it comes from sine of a plus b, where both a and b are equal, right? So let's say this is equals to theta. So we have sine of theta plus theta. That gives me sine a cos b plus cos a sine b, right? This eventually becomes 2 sine theta cos theta only. So it's pretty simple. The other one is cos 2 theta. You can do the same by doing cos a cos b minus sin a sin b, and you'll get 2 cos square theta minus sin square theta. But it has interesting forms as well. You can write this as 2 cos square theta minus 1 and also 1 minus 2 sin square theta. You have to remember all these three forms of cos to theta. In sin to theta, we have just one form, but in case of cos to theta, we have these three forms: cos square theta minus sin square theta, 2 cos square theta minus 1, and 1 minus 2 sin square theta. And depending on the question in the problem statement, we can use either of these. Okay. So basically, what we are doing in the first form, what we are doing, we are converting sine square into 1 minus cos square. In the second form, we are doing cos square is equals to 1 minus sine square. So it becomes 1 minus 2 sine square theta, right? And this one is again pretty obvious. We have tan of a plus b equals to tan a plus tan b upon 1 minus tan a tan b, right? So if you just put a and b equals to theta over here, you get 2 tan theta 1 minus tan square theta, right? Now let's talk about trigonometric ratios of multiple angles in terms of tan theta only. So there might be certain questions where in the expression it's been given in terms of sine to theta, cos to theta, tan to theta, and you're not able to cancel out terms, or basically you're not able to simplify the terms. So in that case, we'll be converting sine to theta into tan theta, cos to theta into tan theta terms, and tan to theta into tan theta terms, right? So that would help us simplify the problem statement. So let's see how do we do it. So we have sine to theta as 2 sine theta dot cos theta. So what we'll do, we'll multiply sec square theta and divide by sec square theta. So one sec theta would be clubbed with cos theta, and that becomes 1 because cos theta multiplied by sec theta is 1. And the remaining sec theta would be clubbed with sine theta, that becomes 2 tan theta. Now we know that sec square theta is 1 plus tan square theta. So you can write sine 2 theta in terms of 2 tan theta upon 1 plus tan square theta, right? Similarly, in case of cos 2 theta, we have cos square theta minus sine square theta. So what we can do, we can take out cos square as common. This becomes 1 minus sine square theta divided by cos square theta. It becomes, I can write cos square theta is 1 by sec square theta, and this becomes 1 minus tan square theta. Again, sec square theta can be written as 1 plus tan square theta. So this becomes this particular format. And obviously, if we divide both of them, we'll be getting 2 tan theta upon 1 minus tan square theta, which we had derived it earlier, right, based on tan of a plus b. So you have to remember these formulas as well for multiple angles. Now comes the third part, that is triple angles. Until now we have dealt with double angles. Now we are dealing with triple angles. So we have the first one is sine 3 theta equals to 3 sine theta minus 4 sine cube theta. Again, we'll be using the brute force method. We'll not be using any trick over here. So it becomes sine 2 theta plus theta. So we have sine A cos B plus cos A sine B. Right. Now again, we'll be using 2 sine theta dot cos theta plus this becomes cos square theta minus sine square theta. Or we'll use 1 minus 2 sine square theta over here because everything is in sine format. Right? Sine theta. Now this becomes 2 sine theta dot cos square theta. You can write 2 sine theta 1 minus sine square theta plus this becomes sine theta minus 2 sine cube theta. So this becomes 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube theta. Eventually it becomes 3 sine theta minus 4 sine cube theta. It was a pure brute force method, nothing else, and we arrived at the formula 3 sine theta minus 4 sine cube theta. Right. Similarly, you can derive for cos 3 theta. Similarly, you can derive for tan 3 theta. But again, you have to remember all these formulas. It's not about deriving them; it's about remembering them as well. So for cos 3 theta, we have just the reverse of this one of sine theta, basically 4 cos cube theta minus 3 cos theta. In case of tan 3 theta, we have 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Now we have trigonometric ratios of some multiple angles, and it's nothing but it's exactly same as multiple angles. So what we are doing over here is we had sine 2 theta equals to 2 sine theta dot cos theta, right? But now what we are writing over here is in terms of some multiple angles, sine theta equals to 2 sine theta by 2 dot cos theta by 2. It's the same thing, right? There is no difference. We can write theta as 2 phi. That becomes sine 2 phi equals to 2 sine phi dot cos phi. It's the same thing, right? This formula and this formula is exactly the same. So you just have to remember the multiple formulas and you'll definitely remember these are multiple angles as well. Now let's look at this particular question. We have sine cube theta plus sine 3 theta divided by cos cube theta minus cos 3 theta. And it's pretty obvious that we have to use the sine 3 theta formula over here. So we have sine cube theta plus sine 3 theta is 3 sine theta minus 4 sine cube theta divided by cos cube theta minus we have 4 cos cube theta minus 3 cos theta. So it becomes, if we take 3 as common in the numerator, 3 sine theta basically, if we take as common, it would become 1 minus sine square theta divided by, I'll just write it over here. If we take 3 sine theta as common, it would give us 1 minus sine square theta divided by, similarly, if we take 3 cos theta is common over here. So we have cos cube theta. Basically, we have 3 cos theta minus cos cube theta. 3 cos cube theta. So we'll be getting 1 minus cos square theta over here. So this becomes 3 sine theta dot cos square theta divided by 3 cos theta dot sine square theta. This one gets cancelled out. This cancel out, becomes cot theta. So we have B as the correct answer. Now let's look at this question. If theta belongs to 0 to pi by 16, then the value of this expression is. So this is a very standard problem, and what we do over here, we start from the inner under root. So we have innermost under root is 2 plus 2 cos 8 theta. Can 2 over here, we can take 2 as common, 1 plus cos 8 theta. Now, whenever you see this kind of format, 1 plus cos something even theta, or maybe just theta, the first thought that should trigger in your mind is 2 cos square theta. Basically, if we have 1 plus cos 2 theta, the first thought that should trigger in your mind is 2 cos square theta. If we have 1 plus cos 4 theta, the first thought that should trigger in your mind is 2 cos square 2 theta, right? Similarly, we have, just make it a thumb rule for yourself. So similarly, we have 1 plus cos 8 theta. So we'll be getting 2 times 2 cos square 4 theta, right? And this becomes under root 4 cos square 4 theta. So we can take out 2 as common outside the root, basically becomes cos square 4 theta. Now here's an interesting part. We know that under root is always positive. So whenever we have this kind of format, under root x square, it is always mod x. It's not x. A lot of people do this kind of mistake, even in the examinations. They write under root x square as x. That is only true when we know that inherently x is positive. But it might be possible that x is negative. But we definitely know for sure under root is always positive. So under root x square is always mod x. Just make it a habit that you have to write under root x square equals to always mod x, right? Now this becomes 2 times mod of cos 4 theta. Based on the same logic, now we have to see if cos 4 theta is positive or negative, and based on that we'll be opening our modulus. So we have theta ranging from pi by 16 and 0. So 4 theta should be ranging from pi by 4 and 0, right? So basically it's in the first quadrant. 4 theta is in the first quadrant, and in cos theta in first quadrant is always positive. So this is always positive. So this comes out as 2 cos 4 theta, right? Now once we have created this, we have opened this particular under root, 2 plus 2 cos 8 theta, that becomes actually 2 cos 4 theta. Now we have 2 plus 2 cos 4 theta over here, same kind of thing. So we can extrapolate it, because we have done all this effort over here. We can extrapolate the same thing over there. So we can write this as under root 2 plus, this becomes 2 cos 2 theta, and this final term becomes under simply becomes 2 cos theta. So this one became 2 cos 4 theta. This entire became 2 cos 4 or 2 theta. And this entire became 2 cos theta. Simply. So eventually our answer is D. Now let's look at these final results. So we have sine theta dot sine 60 minus theta dot sine 60 plus theta equals to 1 by 4 sine 3 theta. So again, let's see the derivation with the brute force method, nothing else. So we have sine theta, and this is sine of a plus b sine of a minus b. So we can write sine square 60 minus sine square theta, right? So this becomes sine theta multiplied by sine square 60 is 3 by 4 minus sine square theta. We can take 1 by 4 is common. So this becomes 3 sine theta minus 4 sine cube theta. Now this is nothing but 1 by 4 sine 3 theta. Similarly, you can derive the formula for cos theta, cos 60 minus theta, and cos 60 plus theta. You'll get 1 by 4 cos 3 theta. And if you divide both of them, you'll get tan theta, tan 60 minus theta, tan 60 plus theta equals to tan 3 theta. We don't have 1 by 4 because obviously it could cancel out when we divide both these formulas. Right? Now let's look at this particular question. Value of cos 20 plus 8 sin 10 dot sin 50 dot sin 70 divided by sin square t. I'll leave this to homework because it's very simple. We have sin theta, sin 60 minus theta, sin 60 plus theta. It becomes pretty obvious. So I'll leave that to homework. You can try this question on your own. So this lecture was till here only, and let's meet in the next lecture where we'll be talking about transformation formula, basically from product to summation, summation to product, and one more topic of sine and cosine series. And that would mark the end of basic trigonometry for PGDBA, right? So let's meet in the next lecture. Thanks for watching.